Good afternoon. My name is Ravi Babu, Assistant Professor in IARE Institute of Technology. Today I am going to starting with in second model system response numerical examples on pulse transfer function. In previous section already we see about the definition of the pulse transfer function and what is meant by pulse transfer function, what is the main functions of the pulse transfer function, and what is the rules of the pulse transfer function. Okay, and we can see the pulse transfer function for open loop system, pulse transfer function for closed loop system. Okay, when the pulse transfer function for applied for in first case, we see that what is before the feedback function, pulse transfer function is applied. After the feedback function, pulse transfer function is applied. We will see. Now, today we are going to discuss about the numerical examples on pulse transfer function. See the first one. I am taking the determine the pulse transfer function of the following system. That is, here the given as R of S is the input function and it is a one pulse transfer function. After this one, we are using here one forward path G of S and another forward path G2 of S. For taking the feedback, we are having the feedback path also, we have the two feedbacks. The two feedbacks are also connected in series. In the forward path also two blocks are connected in series. So H1 of S, H2 of S. But here we are going to applying the pulse where at the before of the function G1 block we are applying the pulse, and when the feedback is coming now, at the time of the feedback, at the first feedback block before I am applying the one pulse. So before going to starting this one, now we are having at the summing block point error detector, that is E of S. When you have to apply the E of S for this pulse function, it is coming to E star of S, star Laplace transform. It is coming to star Laplace transform. Okay, star function, that is nothing but star function. So when seeing the this block diagram, that is the E of S is nothing but it is the summation of the R of S plus and input block, that is input block plus feedback block, that is B of S. Okay, B of S. But the feedback path is I am using here negative feedback. I am using here negative feedback. That's why E of S equal to R of S minus B of S. R of S minus B of S. After that one, in the block diagram, we are applying the pulse. That's why that E of S is coming to as E star of S. E star of S. So already we know apply for input function also, total function for this one. So E star of S is nothing but that is R star of S into B star of S. R star of S into B star of S. Okay, already we know in the previous section we explained that what is when you are going to applying the find out the pulse transfer functions problems. First of all, we have to apply the star Laplace. After that one, Z transform. After that one, again we have to find the final value of the transfer function. So here I am applying here star Laplace. That is nothing but pulse applied. Star Laplace nothing but I have to apply the pulse transfer function. Pulse function. So E star of S equal to R star of S minus B star of S. Convert this one into Z transform. That is E of Z equal to R of Z minus B of Z. From this one we got it R of Z equal to E of Z plus B of Z. That is input function R of Z equal to E of Z plus B of Z. Take this is the equation number 1. What I have to find? Generally we have to find that what is transfer function, that is Y of S by R of S, that is Y of Z by R of Z. We have to find the Y of Z by R of Z. For that one, I am taking the first is input from input command R of S and feedback command B of S, where it is going to joining at the point of the summing point. So E of S. That E of S is I am going to be taking the, for that E of S, it is R of S plus minus B of S. For that R of S minus B of S, so E of S is coming. After that one, what I am doing here? Here I am applying the pulse. When you are going to applying the pulse, that E of S is coming to as E star of S. E star of S. So what happened? R of S star of R star of S minus B star of S. B star of S. It is coming. Okay. So we find the E star of S. After that one, I am applying the Laplace transform. That is coming to, sorry, Z transform. That is coming to E star of S is coming to E of Z, R of Z minus B of Z. From that equation, I want to the input value, that is R of Z. That is E of Z plus B of Z. B of Z. Now, coming for the next one. Now, up to in previous PPT, we will see up to here. Up to here, we will see the calculation part. This block. Okay. So, we find this one. From this one, we find the E star of S. From that one, we find the Z of S. Z of S. Okay. So, now I am going to another one. That is, now I am going to calculating the Y of S. After that one, what we have to do? In case of pulse transfer function, after that one, we have to apply the pulse. That is, Y star of S. Y star of S. After that one, Z transform. Okay, that is Y of Z. This is a procedure. Already we know. In previous section I told. So, go for this one. Now, second block. That is, I want to find here Y of S. For that one, pulse function. That is Y star of S. And we have to find the finally for that one Z transform. That is Y of Z. Output. So, coming for here Y of S. What is the Y of S? Y of S is nothing but here E star of S is coming now, and E star of S is coming. This E star of S and Z1 of S and Z2 of S are in cascade connection. So Y of S is nothing but E star of S into G1 of S into G2 of S. So it is completed. So now I am applying the pulse. Star Laplace. That is star Laplace. I am applying the star Laplace. That is Y of S is coming to Y star of S. And E of S is coming to E star of S is coming to same. G1 of S is there and G2 of star will be there. Okay. G2 of star will be there. Why? Because E1 of S is the already star function. No, it is applied to here. But the second function is not coming to this one. That's why it is coming to G star of S. G star of S. This is the property all of you know. For this, I am going to here apply in last class or in last section already I applied that one is no. That is when x1 of S and x2 of S is there. If you apply for this one star Laplace, so star Laplace, that is x1 of S is constant and x2 of S is coming to as star Laplace. This is the formula. So in this case, I am applying for total function. So it is already star Laplace. So I am taking the same as. After that one, G1 of S is saving as. So only G2 of S is there. That's why I am taking this one, G2 of star of S. Okay. From that one, after this one, I am applying the Z transform. That is Y of Z. So Y of Z equal to, this one is coming to as E of Z, G1 of Z and G2 of Z. That is, which functions is having the star Laplace, for that functions I am writing the Z. Okay, those functions is not having the star Laplace, that one is coming to as a constant term, G1. Okay, this is the property of the pulse transfer function. So, we got the output value is Y of Z equal to, see, E of, which function is having the pulse transfer function, that value is coming to Z transform. Okay, E of Y of Z equal to E of Z, G1, G2 of Z. That is your second equation. So we are completed up to up to this position. Now coming for the third equation. Coming for the third one, when you are going to for third one, that is the feedback is coming in this direction now. So H1 H2 is cascade correction and these are the feedback, and we are having the one pulse. We are having the one pulse. So now I am going to explain the deriving for B of S and B star of S. For that one, I am applying star Laplace, okay, and B of Z transform finally. So coming for what is the B of S? So B of S is nothing but, so what is the Y of Z? You have to write. It is E star of S into G1 G2. So Y of S is nothing but E star of S into G1 of S into G2 of S into feedback. First feedback is H1 of S and second feedback is H star of S. Completed. Okay, this value B of S is completed. Feedback path value. After that one, what we have to do? Apply star Laplace. When we are going to apply the star Laplace, in the first above equation, this one, here star will be there. So only we have to make in the other, already we see the properties of star Laplace. Only for this one only, we have to make in star here. Here. It is completed now. So here I am making only for star here. So here star is came. Okay. So what happened? This part is completed. Again, we are applying a one pulse to feedback function. It is Y of S. Up to here, Y of S. Up to here, Y of S. Okay. Up to here, Y of S. Completed. After that one, we are taking the H1 H2 is feedback. H1 H2 is feedback. But we are applying the pulse. That's why I am taking the star. I am taking the star. So what happened for this one? Again this one, we know the property, same property. In previous point I said no, only for this one only star is coming. Only this one only star is coming. And this is coming to as S transform, for H1 of S transform is coming to only H1 only. H1 only. These are the properties of the pulse transfer function in previous section I will explain. Okay. So we got this value. Okay. After that one, I am taking here E star of S, G1, G2 of S, okay, H1, H2 of S we are getting here. We are getting here. Now, apply here for this equation Z transform. Apply here this equation Z transform. So what happened? Here Z transform, E of Z, G1, G2 of Z, H1, H2 of Z. Where is the S is there coming to Z. Okay, we have got the third equation. So we got the B of Z and we got the R of Z from first equation. Okay, from first equation R of Z equal to E of Z plus of Z. Okay, so from first equation what is that one? R of Z equal to E of Z plus B of Z. Okay, B of Z. So what I am doing, I want to transfer function. I want to transfer function. So for that one, I am substituting there where the B of Z is there from equation 3. From equation 3. So what happened? E of Z okay, E of Z plus this part. This part is true. So go for the next slide. In next slide, I will explain that one. See this one. Okay. It is R of Z, E of Z. Where the B of Z is there, that I am explaining. Enter that value. Take the E of Z is common. What happened? 1 plus G1 into G2, this value. After that one, what is the formula for that one? From second equation, we got the Y of Z. From second equation, we got the Y of Z. So we have to apply that. What is the transfer function? Y of Z by R of Z. So Y of Z by R of Z. R of Z is there. So what is the Y of Z? Formula E into E of Z into Z1 into Z2. Z1 into Z2. Okay. This is your overall transfer function for this block diagram. What is this block diagram? What is this block diagram? The transfer function is E of Z, G1, G2, sorry, E of Z, G1, G2 of Z by 1 plus, see, okay, 1 plus E of Z into 1 plus G1, G2, H1, H2, H1, H2. Okay. Next, coming for one of the important note, that is G1, G2 of Z equal to Z transform of G1 of S into G2 of S. You have to remember this formulas. Okay. So, G1 of Z, G2 of Z equal to Z transform of G1 of S and Z transform of G2 of S. When two Z transformers are multiplied functions, okay, it is coming to as individual. It is coming to as individual. Okay. Next, G1 of Z into G2 of Z not equal to G1 of into G2 of Z. Okay, remember this one. Coming for second problem, that is, in previous section we are taking the only pulse function before the, where at the input section side, at the place of G1 of S before and feedback section at the entrance of feedback section. Now, I am going to apply one more pulse function between the two forward gains. Two forward gains. So, what is the output we have to see? That is nothing but, in previous section, we are taking only this one and this one only, pulse functions. Now, I am going to taking the pulse functions where between the two functions, two forward pulse also. Again, I am taking the pulse function between the G1 of S and G2 of S. Okay, between G1 of S and G2 of S. So, coming for the first one, same previous section model, that is, I am going to finding the E of S. What is the E of S? E of S is nothing but R of S into B of S. Sorry, E of S is nothing but R of S minus B of S. After that one, I am applying here in the block diagram pulse function. So, it is coming to us E star of S. E star of S. So, E star of S equal to R star of S into B star of S. Now, as our properties, we are going for the Z transform for that one. After applying the star Laplace transform, we are going to Z transform. That is, E of Z equal to R of Z minus B of Z. From that one, the input function is R of Z equal to E of Z plus B of Z. Now, I am taking this is the equation number 1. Now, coming for the next one, the up to before the first forward block, we will see that one. Now, I am going to the next two, that is output Y of S. So, I am going to expression of the output Y of S. After that one, I am going to applying the star Laplace. After that one, I am going to finding the Z transform of that one, Y of Z. So, first to take the Y of S formula. So, what is the Y of S formula? That is nothing but E star of, okay, E star of G1 of there, okay, E star of S, this E star of S into G1 of S. For this total function, now I am going to applying the pulse. That's why here coming to as star. That's why here coming to as star. After that one, G2 is there. G2 is there. So we got the function as this total function. Now, express this function. That is, here for this one, here in this one, for this one, you are applying a star pulse function. Here, this pulse function. So what happened? The property of the pulse transfer function, when it is applying nothing but E star is the same as that one, and Z1 star also coming. Z1 star also coming. Okay. So this is the property. Already we know in previous sections. Okay. So that's why E star is there. E star is there. For the G1 of this one, star is coming. Star is coming. This is our total function. Here star is there for this total function. That's why it is the property of the pulse transfer function. After that one, same as G2 of S. G2 of S. So, okay. So it is completed. Now what I have to do? We have to apply the star Laplace. So I am applying a star Laplace. Star Laplace. So what happened? Y star of S. So for this total function, I am applying star Laplace nothing but for the total function, we are taking the star. This star. Okay, like this. So I am taking a star for this last one. Okay. So what happened? So when you have to apply a star, again same star Laplace property. The last term is coming to as star. Here also The last term is came to as star. Similar. Same property I am using. Similar property. Every time I am using this only property here. Okay. So E star of S, G1 star of S, first function completed. Last function is getting as star. Last function is getting as star. So now I am applying the Z transform for this function. So it is coming to as, where is star is there, that function is coming to as Z. Without star, nothing but it is coming to the constant term. Already previous problem I told you. So it is star is there. Z transform Z coming. E of Z. G1 of Z. G2 of Z. Y of Z. Okay. Y of Z. So it is completed. It is completed. Now, what happened? Up to Y of Z is we have to keep. Now I am going to for the feedback section side. Okay. Feedback section side. What is the feedback section? That is B of S. So we have to find the B of S. After that one, for B of S, I am going to applying the star Laplace. After that one, applying the Z transform. This is a Z procedure we are going to take. So what is the B of S? B of S is nothing but this total output. What we have to got in previous section. Okay, E1 star, ES of star, Z1 of E star of S, Z1 star of S, Z2 of star S. So this one. That is from starting onwards. This one, completed. Okay, like this. After that, H1. After that one, total function is pulse is applying for this one. Pulse is applying. Pulse applying. After that one, H2. Okay, so this part is nothing but Y of Z. It is including a function of this total function also. This total series function. And taking it. Okay, after that one, H2. What is it? Why star is coming here? I am applying it pulse. I am applying here pulse. Okay, so we have got this one, B of S value. Okay, we got the B of S value. We got this B of S value. After that one, I am expressing why, because here star will be there. What is the output you are going to see? Okay, what we have to applying there. So when a star function is applied for multiple functions, already it is the property I explain every time. The last function is getting the star. The last function is getting the star. So E1 of star, G1 of star. Sorry, one more. In this bracket, sub bracket will be there. In sub bracket, again we are having the in sub bracket we are having the two functions with star Laplace. So what happened? It is coming to same. It is coming to star. Okay. Again, it is coming to same. Okay. So it is not a star function. No, that's why it is coming to only G2. It is a property also. One more property. It is not a star function. Why? Because the upside star will be there. That is G2 only. Again, it is a last function for total bracket, this one. So that's why it is coming to star. And last term is H of S. H of S. Very clearly you have to write down the equations. If any star is missing, star Laplace, total function output is also going to be changing. Total function output is also going to be changing. So carefully you have to express the equations. Okay. B of S is having the pulse function, feedback pulse function. That's why for total for that one we are taking the pulse. Okay, for B of S. But here H2 of S is there. Okay, but what happened? This function is nothing but total function pulse is before that one is Y of S. Again, Y of S is having the one pulse between the two forward path, and before the forward paths one pulse is there. That's why it is coming to as these functions. These functions. Okay. So we got the value. This value. Apply for this one. Star Laplace. Okay. This is a new position now. First write the main equation. After that one apply the star Laplace. When you have to apply the star Laplace, what happened? E star, Z1 star, Z2, H1 star, H2 star. Last function is coming to star. Last function is coming to as star. So for this one, apply Z transform. Apply Z transform. That is coming to as V of Z equal to E of Z into G1 of H, G2 of H. For G2, there is no S star. Why? Because it is not a star function. It is not a star function. Okay. So H1 of Z and H2 of Z is there. Okay. Now this is feedback completed. Probably what is the interior section similar explained now. So from equation 1 and equation 3, R of Z equal to E of Z plus R of Z equal to E of Z minus E of Z plus B of Z. R of Z equal to R of Z equal to E of Z plus E of B of Z. First equation. Coming for third equation, solving for first and third equations, we got this function Z1 Z2 by 1 plus Z1 of Z, Z2 of Z and H1 of Z, H2 of Z. See that one. In previous problem, here we got the E of Z multiplication factor. Here not is getting. Okay, not is getting. That is the function, pulse function. Diagram is same, but only one extra pulse I am adding here. One extra pulse is adding between the two forward paths. So we are getting the here change of the pulse function. Okay, between the in first problem we will see the pulse function at the before G1 and feedback path H1. Whereas in second problem we are seeing the pulse function before the first forward path and after the exact feedback path H1 before, but between the two forward path blocks we are having the transfer pulse function, this one pulse function. So the output is going to be changing. Okay, the output is going to be changing. Okay, now I am going to another problem, that is we are having the same forward path same is same. First forward path one pulse function is giving, second forward path one more pulse function is I am giving, but I am taking the feedback path as two parallel feedback paths. In that one, I am going to taking for one function, that is H2 function, pulse function in feedback. So what happened you have to see. So similarly, same as first E of S equal to, so sorry, here what happened, two feedback is there, that's why R of S equal to R of S minus B1 of S minus B2 of S equal to E of S. Okay, E of S. So for this E of S, apply star pulse function, that is E star of S equal to R star of S, B1 star of S, B2 of star of S. Apply Z transform. Yes, same process, but some changes in diagram. E of Z, R of Z, B1 of Z, B2 of Z. From that one, input R of Z equal to, okay, input R of Z equal to E of Z plus B1 of Z plus B2 of Z. That's all. Okay. This is your equation number 1. Where is the second equation coming? At Y of S. Y of S. So, Y of S, first find the Y of S, star Laplace, Z transform. Y of S equal to this total input part. And apply the Z transform. Next, here I am taking the first feedback, H1 of S. So, that is B1 of S. B1 of S equal to, the output is there, no? That output value, that is this one. To here. Okay. If you see the diagram, you can see directly. Star function is there, E of S into G1. For G1, again one pulse is given, no? G2. And for G2, there is no pulse. That's why G2 of S. That's all. Okay. That you see there. No problem. After that one, I am applying here for B1 star Laplace. So this one is star, this one is star, this one is not star. Last function is getting star. Okay, you know the last function is getting the star function. Okay, after that one, convert that into Z transform. That is B1 of Z equal to that part. Same procedure I am going to follow. Coming for the fourth one, that is for feedback 2. Okay, for feedback 2, B2 equal to same. B2 equal to B2 of S equal to this Y of S for values into H2 of S. This is your Y office into H2 office. Okay, H2 office. So came after that one, star office J transfer. Star office J transfer. So coming for the equations from 1, first equation is for only forward path, third equation is first feedback path, fourth equation is second feedback path. From that one, we got this transformation. Okay. Now, today we completed the numerical examples on pulse transfer function. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.